in order to graph this equation, I'm first going to rewrite it in slope-intercept form. So I'm going to move the x term to the left side to get 7y equals negative 5x plus 21. And then we can divide each term by 7 to get the y by itself. And that's going to give us the equation y equals negative 5/7 x plus 3. Now in this form, we can graph it very quickly because we know the y-intercept and we know how one point moves to the next point. So down 5 over 7, or up 5, and then reverse 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so this here would be our line, and I'll try to draw this with a straight line. Okay. So B, calculate the intercepts algebraically. So again, for the intercepts, these are all about the zeros. The 0 for the x and the 0 for the y. So I'm going to start by plugging 0 in for y, and then this is going to allow me to solve for the x-intercept. Okay, so here I'm going to actually multiply everything by 7 first. So we get 0 equals negative 5x plus 21. Then I'm going to move the 21 over, and then divide by the negative 5. The negative would be positive. And to write it as a decimal, so we can check our graph, 21 divides 5, sorry, 5 divides 21, 4.2 times. So our x-intercept is the coordinate point, 4.2, 0. Okay, and then for the y-intercept, we're going to plug 0 in for x. So y equals negative 5/7, 0 plus 3. And we know the y-intercept should be 3, but here's a way to prove it. Negative 5/7 of 0 is 0, and 0 plus 3 is 3. So the y-intercept is the 0.03. So those are the intercepts. And notice they match the graph. There's the 0, 3, and there, I believe, based on the drawing, I would agree that that looks like 4.2-ish. Okay, so number 3, does your calculation match your graph? Yes, it does. Okay, number 4, use the equation to calculate the value of y when x is negative 8. So here, we're looking for y, and we're going to plug in the negative 8 for x. Okay, so here, all we have to do is really type this in our calculator, or do it by hand, whatever you prefer. But when we do that, that is 61/7. You can just type this in your calculator, and that's going to give you that value, 61/7. Okay, number 5. So here we want the value of x when y is negative 5. So negative 5 is the y, and here x is going to be the unknown. So to solve this equation, I'm going to multiply by that 7 again. So negative 35 equals negative 5x plus 21. I'm going to move the 21. If we move the 21, that's going to give us negative 56 equals negative 5x. Then we can divide by negative 5. So we get x equals 11.2. Or you can leave it as 56 over 5. Note that the negatives would cancel, but that's 11.2 exactly. Okay, so number 6, list 3 solutions seen on the graph. So looking at the graph, we have, besides the x-intercept, we plotted 3 lattice points. So those would be nice solutions for 6. So you could say negatives, this point here is negative 7, 8. This point here is the 0, 3. And this point here is 7, negative 2. The other one that we could list would be our x-intercept, which we calculated to be 4.2, 0. So those are 4 of the 3 that we could have. Okay, then number 7. So to list points not on the graph, what I'm going to do is I'm just going to pick large x values and then calculate the y value that would go with them. Now here, notice I'm choosing 14, 21, and 28. And I'm actually choosing these numbers on purpose. Since our equation here has over 7, or dividing by 7, I'm choosing x values that divide 7 and become a whole number. So now when I calculate, I'm going to have y equals negative 5/7 times 14 plus 3. That's going to be a whole number. So for example, this is negative 7. Then if we did y equals negative 5/7 times 21 plus 3, that's going to be negative 12. And then y equals negative 5/7 28 plus 3, that's going to be negative 17. So since I chose these x values that were off the graph, when I find the y values, there's no doubt that these solutions, one, are solutions, but also they do not appear on the graph. Okay, number 8 is negative 21, 15 a solution. So to be a solution means that if I input these values, I get a true statement. Now, I could use this equation, the equation I've been using all along, or I could use the original equation for every one of these problems. Just to change it up a bit, I'm going to use the original equation and say 5x plus 7y, and we want to know if that equals 21. So 5 times negative 21 is negative 105, and 7 times 15 is 105 equals 21. So then the left side would be 0. 0 equals 21. That is not true. So the answer is no. It is not a solution.